Hello, YouTube, and welcome to a new series. This is Alzoru Discusses Paleobiology, and allow me to start at the beginning. Imagine, if you will, a field of asteroids and other space object things. You see a bunch of rocks in space, basically, all kind of coalescing together under the force of gravity. All these rocks come together and form one big spherical rock, the Earth. The Earth, at this point, was a molten mess. A bunch of molten magma and lava. Just, all this volcanic wasteland, and where absolutely nothing could happen. As the Earth began to cool, more and more, just things started hitting it, ice meteors, other meteors, some more asteroids, and at some point, a particularly large impact that made quite a bit of a mess. Which, if you've watched Bill Wirtz, you know exactly where this is going. That big chunk of stuff is now the moon. This period of time, where absolutely nothing could have possibly lived, at least as far as we know, was called the Hadean Era. The Hadean Era, well, it's called that because it's quite hellish. Or at least, we certainly think it is, or was. However, there is some small evidence that suggests that life may have been around during this time in the form of zirconium crystals that show strange processes going on that we usually associate with life. So there's a small chance that even in some parts of the Hadean, there may have already been some microbial life on Earth. But we know for certain that it was definitely around in the next era, the Archean Era. The only thing around during this time would have been, well, Archaea. What are Archaea, you ask? Archaea are these little bacteria-like things. They're not quite bacteria, but they're most similar to bacteria. They're these single-celled organisms that just kind of exist in very extreme environments, like most, if not all, Archaeans alive today are extremophiles, and it's not a big stretch to say that a lot of the Archaea back then were as well. These Archaeans most likely first sprung up around deep sea vents, kind of like the ones we still find to this day. And heck, the bacteria down there around the hydrothermal vents might be related. Who knows? And for the longest time, that may have been the only place where life really existed. Just a bunch of Archaeans just kind of hanging around hydrothermal vents. And some other really weird, extreme places. True bacteria would eventually arrive. And then, well, at some point, I don't know exactly when, cyanobacteria began to appear. And before that, there was this other kind of photosynthetic bacteria that may or may not have been purple. But the kind of photosynthesis we know today was pioneered by the cyanobacteria, which are still around today, by the way. They started farting out oxygen, and they've got so prolific that, well, let's just say that the oxygen levels in the water and in the atmosphere got really bad. Why was this a bad thing? Well, everything alive at the time was basically allergic to oxygen. This event is known as the Great Oxygen Catastrophe, and this catastrophe was, well, catastrophic. A lot of things died off during that time. And, on top of that, the iron in the water all oxidized, and that is where we have... What's that? Let me try that again. And that is where most of our iron ore comes from. So, yeah, most of our iron ore comes from a time when a bunch of iron in the sea rusted all at once, fell to the bottom, and then got covered in layers of sediment. Fun stuff. In that regard, you could almost consider her iron ore kind of like a fossil. I might be exaggerating a bit when I say all of our iron ore comes from this, but a good chunk of it certainly does. Now, what happens next, you might wonder? Well, evidently some bacteria managed to survive the Great Oxygen Catastrophe, otherwise we wouldn't be here. What happens next is that somehow or another, some bacteria ended up living inside of larger bacteria. We're not entirely sure how this happened and how the smaller bacteria didn't get digested, but this basically he began the road towards the true eukaryotes. Soon enough, there were eukaryotes around. Eukaryotes are any organism whose cell has a nucleus, and that includes us, and plants, other animals, any kinds of protists, fungi. Basically, if it's multicellular, it's a eukaryote. And even a couple of things that are microscopic are also eukaryotes. And for a while, things just continued to be unicellular. It was just kind of the way things were for quite a while. Though, some bacteria and some eukaryotes did start living in colonies. Oh, and also, apparently, the Earth was a snowball a couple of times. That sucked. But that wasn't really enough to kill all life, evidently, so... yeah, good thing there. But then, something very strange began to happen after the snowball Earth periods. Right at the beginning of something we call the Ediacaran period, something began to change. Multicellular creatures began to emerge. Things that were neither plant nor animal. They were just there. We know them today as rangiomorphs, and these are some of the first multicellular organisms to ever exist, as far as we can tell. And this, I think, is where I should explain something. There are two eons in the Earth's history, as we call them, Proterozoic and the Phanerozoic. Usually, the Proterozoic usually ends right before the Cambrian explosion, but if you ask me, it should start at the beginning of the Ediacaran. You see, all Proterozoic really means is life before animals, or before animals, really. But, the thing is, the Ediacaran period gives us our first look into what most likely were animals, and in some cases definitely were. We have things like Kimberella and Dickinsonia that almost certainly were animals. So I think that the Phanerozoic, the time after animals, should be moved to the beginning of the Ediacaran. So yeah, Avalon explosion for the win. I'll talk more about the Ediacaran period and what it really means in the next episode, but for now, this is Alzor Dura signing off, and thank you for watching.